Universal Verification Methodology, UVM. Introduction. Universal Verification Methodology is a standardized methodology for verifying digital designs and systems. It provides a set of guidelines, APIs, and a methodology to create robust and reusable verification environments for complex electronic designs. Key features of UVM: modularity and reusability, component-based architecture, transaction-level modeling, phases and sequences, configuration and factory, coverage and analysis. Test bench architecture of UVM. Components of UVM test bench: UVM agent, UVM sequencer, UVM scoreboard, UVM environment. UVM agent. Purpose: agents in UVM serve as interface adapters between the test bench and the DUT, managing the communication and transaction flow between them. Functionality: agents encapsulate driver and monitor pairs responsible for driving stimuli into the DUT and capturing its responses, respectively. They provide a layer of abstraction for interfacing with the DUT's input and output ports, handling protocol-specific details and timing considerations. UVM sequencer. Purpose: sequencer in UVM are responsible for generating stimulus sequences that drive transactions into the design under test or initiate specific test scenarios. Functionality: sequencer encapsulates stimulus generation logic and define the behavior of the test scenarios. They control the flow of transactions and can include constraints to ensure realistic stimulus generation. UVM scoreboard. Purpose: scoreboards in UVM are used to compare the expected results against the actual results produced by the DUT during simulation. Functionality: scoreboards analyze and check the correctness of DUT outputs or responses by comparing them with expected values or reference models. They track transactions generated by the test bench and received from the DUT to ensure functional correctness. UVM environment. Purpose: environments in UVM provide the top-level structure for assembling and configuring the test bench components, including sequences, agents, and scoreboards. Functionality: environments orchestrate the overall verification process, coordinating the execution of test scenarios, managing resources, and controlling simulation flow. They encapsulate the test bench hierarchy and provide a centralized location for configuring and controlling verification components. Phases of UVM. Build phase, connect phase, end of elaboration phase, start of simulation phase, run phase, extract phase, check phase, report phase, final phase. UVM phases block diagram. Build phase of UVM. In universal verification methodology, the build phase is the initial stage of constructing the test bench hierarchy and configuring various components. During this phase, the test bench infrastructure is set up, including the creation and initialization of verification components, such as agents, drivers, monitors, interfaces, sequences, and environments. The build phase ensures that the test bench is properly constructed and prepared for further verification processes. Connection phase of UVM. In universal verification methodology, the connection phase occurs after the build phase and is responsible for establishing connections between various components within the test bench. During this phase, the communication paths and interconnections between different verification components, such as drivers, monitors, and interfaces, are configured and finalized. End of elaboration phase. In universal verification methodology, the end of elaboration phase follows the connection phase and occurs before the simulation begins. This phase is critical for finalizing the test bench hierarchy and resolving any remaining connectivity issues. Start of simulation phase. In universal verification methodology, the start of simulation phase occurs after the end of elaboration phase and marks the beginning of the actual simulation process. During this phase, the simulation environment is prepared, and any necessary pre-simulation tasks are executed to set up the simulation environment properly. Run phase. In universal verification methodology, the run phase is a significant stage where the actual test scenarios are executed, and stimuli are applied to the design under test. This phase involves the generation of test sequences, driving stimuli to the DUT, and monitoring its responses. It runs many phases parallelly like reset, configure, main and shutdown. Extract phase. In universal verification methodology, the extract phase occurs after the run phase and involves capturing and extracting relevant information or data from the simulation for analysis and verification purposes. This phase focuses on gathering various metrics, such as coverage data, transaction information, and other simulation-related details, to assess the completeness and effectiveness of the verification process. Check phase. In universal verification methodology, there isn't a standard phase called the check phase. However, it's common to have a phase dedicated to checking and verifying the correctness of simulation results, which can be considered a part of the overall verification flow. This phase typically occurs after the extract phase and involves analyzing the collected data to ensure that the design meets the specified requirements and that the verification goals are achieved. Report phase. In universal verification methodology, the report phase occurs after the completion of the simulation and verification process. During this phase, various reports are generated to summarize the results of the verification effort, including coverage data, simulation statistics, and any issues encountered during verification. Final phase. In universal verification methodology, the final phase occurs towards the end of the verification process and involves wrapping up various activities to conclude the verification effort effectively. While there isn't a standardized phase explicitly named final phase in UVM, this phase encompasses several crucial tasks aimed at ensuring the completeness and correctness of the verification process. Topology of RUVM simulation. The given diagram shows the topology of RUVM simulation. Here we used three classes which are named as A, B and D respectively. Simulation of RUVM. To start the simulation of RUVM, we have to log in to the server and type the following command, that is exeats sim-f option uvm.txt phases_uvm.sv. Here is the simulation of RUVM. You can see that it has topology as we have seen before and also has all the phases of UVM. Thanks for watching.